Hi everyone and good evening and welcome to another meetup in the Cloud Transformation series by Forefront Consulting. We are of course thrilled to have you here and we are extra delighted for those of you who tune in for the first time. So a warm welcome to you. You are all in for a treat tonight since we're going to have two super interesting sessions. And the main topic for tonight is modernizing integration for effective product teams. And we have two sessions for you guys. The first one held by our partner IBM, presented by Kim Clark, covering integration decentralization. And the other one is held by the frontier Björn Löfvoet, who will hopefully arrive shortly, and also Anders Persson, who is here in the panel. And you guys will take more of a hands-on look at strategies to modernize Java EE applications in use of cloud-native technologies such as Quarkus, Kafka, and Red Hat OpenShift. But before we begin, I would of course introduce myself. My name is Gustav Eggers. I'm a consultant and developer here at Forefront. Currently working with integration and API management at one of our customers. And as mentioned, here in the studio, I have Anders Persson, consultant at Persons IT. And you're going to have a more deeper introduction of yourself during the session later.
Yeah.
But first of all, I would like to welcome you. And how are you feeling today?
I'm feeling fine, thank you.
Great. I like what I hear, and I hear what I like. We also have Oskar Schnell with us. He will attend on the live feed, answering all your questions in the YouTube commentary field. So please, folks, just shoot all your questions and wonderings, and we will have a wrap-up in the panel afterwards. But Oskar will also answer your questions while the session is ongoing, so to say. But before we dive into the heart of the matter, I would first like to give you a short brief about Forefront Consulting. We are a consultant firm with 400 employees spread over 6 different locations in Sweden. And since the start of 2008, we've been driven and thrilled about helping our customers with digital transformation. We are operating through 3 divisions. We have channels, mostly working with service design, user experience, and modern workplace. Also management, they mostly work with IT management and enterprise architecture. And tonight is all about technology, mostly doing system development and analytics in the cloud. Technology obviously involves heaps of technologies. And at Forefront Technology Division, we are engaged in the entire stack. Hence, it is a lot of frameworks, which you can see. But tonight, we will mainly be focusing on the integration stack and frameworks such as Quarkus, Kafka, and Red Hat OpenShift. Also talk a lot about the event streams, which also will be a topic in the sessions. We are really delighted to do this event along with our partners for tonight, IBM and Red Hat. Thanks a lot for making this possible, and we are really glad to have you here with us. And of course, also Forefront Consulting, who is the host for tonight. So this is the agenda I have for you guys. It's going to be as follows. First, a short welcome. And after that, Tim Clark will run his session about integration decentralization. We will have a wrap-up in the panel afterwards. And after that, the stage belongs to Anders and Björn Löfvoet, who will take about modernizing Java EE applications using frameworks such as Quarkus. How to play? I mean, the videos are pre-recorded. Speakers panel will take part after each session. But if you have any questions during the session, just please shoot them in the commentary field, and we have people there answering them as well. If you are interested of material afterwards or have any questions whatsoever regarding the content, partnership and so on, please do not hesitate to reach out. And my email is there. It's gustav.eggers@forefront.sa. But enough with the talk, I would say. I think we are ready to ramble. And having that said, I'll leave the stage to Kim Clark, integration architect at IBM. Enjoy.
My name is Kim Clark. I'm an integration architect working for IBM in the Hursley Labs in the UK. And I cover IBM's integration portfolio, and I've been working in the integration space for maybe a couple of decades now. Over that time, I've been watching integration landscapes change, and one of the things I'm heavily focused on is describing that in what we call agile integration. And it sort of charts how integration landscapes have changed over the years from, as you see on the left-hand side of the chart here, a more sort of centralized enterprise service bus with a deep skilled team and a single runtime perhaps that's actually containing hundreds of integrations that eventually can begin to become a bottleneck. We've seen a move to more containerized integration where we decouple the individual integrations into smaller pieces, enabling them to be changed in a more agile fashion. And we're following what's going on in the application space, of course, as microservice architecture is doing exactly the same thing for applications. API management, of course, is allowing us to expose things across the environment and outside, potentially the enterprise as well, and so making the integrations we've created more accessible. So what we're really here to talk about is decentralization. And in fact, as we move from column 2 to column 3, what we see is an ownership change. The integrations that are now containerized can be owned by application teams. And so the application teams can start to look after those integrations, potentially even create those integrations themselves. So really we're giving teams more autonomy, allowing them to build, maintain and change their own integrations. And that's a good thing in the sense that it allows the teams to move at the pace that they need to move. But there's a downside as well, which is potentially a loss of governance across the environment. So this is kind of a utopian architecture. It's saying, you know, if we could build the perfect architecture, it would have each application owning its own integrations, only exposing sets of APIs and potentially emitting events to enable people to find the data or change the data inside that application domain. A more realistic view would be to say that there will be a mixture of existing centralized integrations. Many of those will continue to run, but they may even continue to run in a centralized enterprise service bus. There may be simply no reason to change that. Some of them could be broken out into containers, but still looked after and run by the central team. And then as we move further to the right-hand side, we're starting to see that decentralization happening. Some of the teams taking on their own integration, some of the integration perhaps happening in managed environments like an integration platform as a service. Looking at this just purely from the integration engine perspective, I mentioned that we'd be breaking these down into smaller pieces, making use of technologies like containerization. The aim with containerization is to be able to build much more lightweight components. That allows you to have a much greater agility in terms of the rapid changes and life cycle of creating integrations and deploying those integrations. You can scale containers up and down independently of one another and make really good use of the underlying capabilities in the cloud-native infrastructure. It's not particularly unusual to discover that an enterprise has hundreds of integrations. That's a fairly common number, especially for large institutions like banks and insurance companies. And so what we're saying here is let's see if we can break that down into containers that are smaller in size. And that enables us to get this sort of agility that we desire. So each integration can be changed independently of the other ones. It can be handed to different teams to actually work on it. They can deploy it safely without affecting anything else. They can choose versions, for example, of the runtime that sits underneath it, and use the latest fix pack, for example, because it has a new feature or because it's got a security requirement or a security fix. So very, very powerful in terms of allowing this sort of decentralization of the integrations. And this is what we've been focused on for some years now in App Connect Enterprise. So some of you may know that as IBM Integration Bus, but version 11 of that product is App Connect Enterprise. And it's been written, to focus on being cloud native, to focus on running in containers in the way that you should run things in containers. And a lot of that comes down to changing the way that things are built and deployed. One of the things we could talk about here is what it means to build a topology for the product. So App Connect Enterprise, for example, in the past, you would have had to build your two HA pairs of servers, you'd have to set up an HA manager, you'd have had to build the load balancing across between the two, set up a DR site. Everything you're doing is very specific to the product and so on. In a container environment, you just specify declaratively what it is you're trying to achieve, and that could be stored effectively as code in a Git repository, for example. And then when you come to deploy your container, you're really just telling Kubernetes, so telling the orchestration environment what it is you want. I want so many replicas of this. I want them spread across these zones. I want you to balance the workload evenly. And the container orchestration platform gets on with doing that in a standardized way. And the beauty of this is that it's the same across all different capabilities. So whether you're standing up queues with IBM MQ, or whether you're standing up integrations with App Connect Enterprise, or indeed whether you're building API Connect, an API management system, you're using Kubernetes commands to achieve that, and you're using Kubernetes instructions in order to make that happen. So it's a operational consistency across different products, and things are working in a homogeneous way, in a standardized way. Another aspect to this is the automated pipeline, and this really moves us towards being able to provide a standard pipeline for anybody to use, so that the focus is really on just building the integration. You really can just lay down the binaries of App Connect Enterprise. You can lay down properties files to decide how you want it to be configured. The actual integration code, that's just laid down on the file system as well, and then you build an image from that and you hand it to Kubernetes, and Kubernetes will deploy that for you based on the specification we're talking about in the previous section. So that whole building of an automation pipeline is much more straightforward, and we can templatize much of that so that you can have standard images that you're building from, and even standard integration. So maybe all you're changing in the end is just a mapping file to allow teams that aren't integration specialists to inherit all the good practices from the templates, and then just do the final piece of work on top to deploy something. So we can see the roles changing quite dramatically, and if you look on the left-hand side, you can see that there's a lot of manual operation required towards the bottom of the stack, and there's a lot of work to set up and provision all the different pieces. And as you move gradually towards the top, you're still needing quite a lot of genuine product skill in order to be able to do the pieces, even when it comes to the artifact creation. What we're trying to do on the right-hand side in this more cloud-native approach is automate and templatize as much as possible. So even the building of a topology is done effectively by the container orchestration system. We're automating things like the build pipelines, we're automating the build of the topology itself, perhaps even adding templates for common styles of integration, so that the developer at the top no longer really needs to be an integration developer, he could be an application developer. And the people working on the looking after the environment, we class them as a site reliability engineer that's focused on automating the platform rather than somebody that's having to do day-to-day manual operations to keep the site running. And it also makes it easier for example, you to provide a more managed service, whether that's a managed service that you look after internally or whether it's something you buy from a vendor. But it's much clearer now what the expectation is in terms of what's managed and then what's worked on at the top level. Let's take a look at this from another angle. API management really has been focused on decentralization right from the start. The whole idea really is to create a capability that enables a team, initially it was integration teams, to be able to expose integrations as APIs, but it very quickly also got adopted by application teams. The idea being that they could expose their own APIs without having to turn to a specialist in integration or in gateways in order to expose their APIs. This has a significant effect as we start to look at more complex microservice landscapes. We see that the microservices are broken up into groups of microservices that are related to one another, and those are our decentralized sets, and those become applications, if you like, that are exposed through an API gateway, and anybody who wants to access the microservices and the data that's sitting within that application must come through, if you like, the front door of the API gateway. And so they become really critical in controlling the complexity, but also in terms of creating a consistency in the way that we're exposing APIs across the landscape. API management isn't just a gateway, of course. What it's bringing to the table is the API manager, and it's really the API manager that's enabling teams to come and define and administer their own APIs. Those get pushed onto the gateway and configured onto the gateway without you having to understand the gateway. So that's the decentralization aspect. And then also the portal. So being able to push APIs into a portal and allow developers that want to use your APIs to come to that portal, discover what APIs are there, subscribe to use those APIs. And so that automated onboarding process that you can set up is really critical to enabling the teams to be free from having to set up detailed contracts between each individual team. The gateways are designed to be multi-tenant in nature. They're designed with strong access controls to allow different teams to manage their own APIs. So the team implementing one application can come in and expose their own set of APIs on a shared gateway, but with complete control over just their APIs, and they can't touch anybody else's APIs in terms of definitions. We can, of course, have multiple gateways. We might be decentralizing our landscape somewhat across multiple clouds, and so we might have parts of our landscape sitting in different vendors of public cloud potentially. But the advantage of having a central API manager looking after those gateways is that we can start to get some of that control back. So yes, we have decentralized down into lots of different places. Yes, we have got teams working on different APIs at the same time, but they are all working through a centralized set of policies. So with our product API Connect, what we've enabled you to do is to have policies that are automatically pushed out to these gateways that enforce security capabilities, for example, to start to bring back some of that consistency across the different environments where the APIs are deployed. There's a big challenge here, not just in API management, but generally in the way that we're handling this decentralization in terms of the skill set that we previously had in the team that used to deploy and look after these environments, the team that knew, for example, the integration engine in great depth. How do we get that knowledge pushed out into the teams that need it? And so we see sort of different techniques here. Initially, we quite often see that team performing secondments out to those application teams to share the knowledge that they have and to understand the challenges that those teams are going through and start building things in terms of patterns for them and working out policies that will be able to be used by that team but can then potentially be shared by other teams. And then over time, we move to models that we typically see in the microservices world, like guilds. And a guild is sort of a community of practice, if you like, around a specialism like integration, where they get together on a regular basis and discuss how things are being done in different teams. And so rather than a top-down kind of ivory tower way of controlling the way that things are done, the guild is aiming to bring those ideas out from the teams themselves and try and take lessons learned and then elevate those up to the enterprise. Let's take a look then at the actual protocols and transport used to communicate between different parts of our architecture. And of course, there's a fairly ubiquitous use of HTTP for APIs and previously web services, but there's also still much use of messaging, traditional messaging, like our product IBM MQ. That's embedded in many organizations and running the core asynchronous transport. And we're also starting to see some new types of asynchronous communication, and we'll come on and talk a little bit about Kafka in a moment. So what we see is a move from where we used to be, where, for example, IBM MQ used to have to be installed on the actual application runtimes themselves, and the application teams had to know how to look after that, running local MQ server, or indeed get a specialist in to assist them with looking after that. And we're moving to more of a remote communication with queue managers. So the queue managers would be remote, the applications would talk to them as a service and start to see them as a service. And that means that they can be deployed in a completely different way. We can start to package the messaging capability as a service, as something that's either easily deployed through containers or could even be deployed as a physical appliance. We have a physical MQ appliance now. And these enable very easy ways to create and administer queue managers rather than having to build them up in a way that was required deep specialisms. And that also allows us to set up communication across different clouds as well. So you can have MQ on cloud as a managed service. You can deploy MQ into containerized environments in a very straightforward fashion using the sort of operator net capability we have in OpenShift today. So there's lots of ways to deploy MQ in a very straightforward way, very portable way across different clouds, and allow the messaging to move between those clouds. So assured delivery across those clouds is really where MQ is bread and butter, is ensuring that when you send a message, it gets to where it's going to go, regardless of what's in between in terms of the quality of the network or anything else. But we're also starting to see a move to the use of events. So a good example of that would be Kafka. Apache Kafka is an open source project, and we have a productionized version of that in IBM Event Streams, which is part of the Cloud Pak for integration. And Apache Kafka, instead of using queues where the messages are deleted as you read them from the queue, instead we have a log of events, which is an ongoing history of all the events that have ever happened. And there are many different patterns here. I've got a link to a presentation that goes into a lot more detail on the different patterns that are there. But a good one to relate to this concept of decentralization is the idea of projections. So you could have a back-end data store that you don't want to communicate with directly over APIs because perhaps it would put too much pressure on that system with the new uses that you've got. So trying to retrieve people's account balance on a regular basis through the day is something that system just simply wasn't designed for. So let's push the change events into an event log and then have your applications read from that event log and build a local data store of the information that you wanted from the backend data store. You can now get to that data whenever you need it in a low latency fashion. You can store the data in a form that you want. It could be a different kind of data store altogether. You could be using a Redis database or a Mongo database. And what do we mean in terms of decentralization? Well, this is effectively saying that the team that's looking after the mobile application are now completely decentralized from the back-end data store. They now have their own version of that data. They're building that data store off of the event log, and they could rebuild it from the event log if they want to. They don't even have to go back to the data store for that, because the event log continues to be there. And so it allows them some significant autonomy in terms of how their application is working in a runtime sense. So it provides a way of decentralizing from a back-end data store and providing some qualities of service that we wouldn't be able to get in another way. Decentralization at first glance seems very much about people and how we decentralize ownership. But hopefully, as you've seen, it's also related to the architecture and, of course, the technology that sits underneath it. Plenty more information on agile integration that you can go and explore at your leisure, and information, of course, on IBM's Cloud Pack for integration.
Thank you heaps, Kim Clark, for that super interesting session, and thank you, IBM. A super interesting topic to start with that, Anders. We are really delighted also to see that it's some good questions ongoing there in the live feed. Thank you, Oscar, for answering those, and I really hope that you learned something from the session Kim Clark just had. Questions about on which platforms you can run IBM integrations at, and also if IBM's got any references around Cloud Packs. So please have a look at those in the live feed for the answers on that. As mentioned, Anders, super interesting, really. Yeah. It's from a really broad and interesting perspective that Kim really takes height for why it's so important with modernization, and it's so much about ownership and the team and so on. But we also, Kim is also talking a lot about Kubernetes containers, and I was wondering, apart from the integration aspect of it, why it's such a talk in the town at the moment with Kubernetes and containers?
Yeah, I would say that there are advantages in production, but especially it's an advantage in the test environments, where you can spin up a lot of environments. During development, where it's easy to have a lot of environments as well. Yep. So, not at least those things there are advantage in those areas. Indeed. Especially.
And those things turn water into wine. Yeah. Well, having that said, once again, a big thank you to IBM, and a big thank you to Oscar and Kim in front of all. We are gonna move forward now for our next session, which is modernizing Java EE applications by using Quarkus. So you are in for a treat there, Anders. Are you ready?
Yep.
Yeah. Then we leave the stage to Björn and Anders.
Hello, and welcome to this talk about modernizing Java EE with Quarkus. First, a little bit about ourselves speaking here today.
Hi, I'm Anders Persson, and I work as an architect, designer, and developer focused on Java backend. As a consultant, I have had the privilege to work with both smaller and larger companies for more than 20 years.
And my name is Björn, and I have a background as a developer, but recently I've moved on to mostly work as a solution architect and what I would like to call a container platform plumber. I've been working with Java and integration as a consultant for more than 7 years. And now we'll go through briefly the agenda for today's talk.
I will start by telling a little bit about the challenges with older platforms. Then I will take some real-life examples about modernization patterns, and finally I will talk a little bit about how we can simplify future version upgrades.
And then I will move on to discuss what kind of requirements you can have on modern platforms, and then move on to a quick introduction about the Quarkus platform, And then we'll do a quick demo case about Quarkus.
Even if many older systems do their job, there are a number of challenges with older systems. Some common challenges are license costs, where you can evaluate if you can migrate to cheaper products like JBoss or Postgres. I will not talk more about that, but if you are in this situation, there may be money to save. Another challenge is maintainability, where, for example, older versions of frameworks may cause time-consuming troubles to solve. This may be both costly and affect time to market. It may also be hard to find competence for older platforms. It may also have a negative impact on operation. Scalability, availability, and performance may be a problem in some organizations. Finding competence may also be a problem. If it had not been for the corona, I would like to hear about your challenges as well, but at least you can think about them yourself. You probably have a picture of the beautiful future architecture in your organization. You hopefully also have a picture of the existing systems. The challenge is often to find the roadmap from today's systems to the future architecture. Normally, the transition has to be made at the same time as the systems deliver new value to the organization. This means that it's important to be able to deliver value to the organization early in the roadmap. Value may be different in different businesses. What is value in your organization? The roadmap also has to be possible to perform in a technical way, and it should not add unnecessary extra work. This means that every step in the roadmap should have a purpose and deliver value. On the other hand, every intermediate state of the systems doesn't have to be architecturally beautiful. You need to be pragmatic, but you should have a plan for it. On the next slides, I will show some real-life examples what I mean with this. The first example is an old payment platform that did its job well. We needed part of the payment information for a number of analyses. The solution was to publish all payments as events on a Kafka topic in a common information model. As the payment platform was too old to talk to Kafka directly, it posted the payments to a REST service that publishes to the Kafka topic. This is actually an example of an architecturally good solution with good decoupling. It's easy to add new listeners, and that has been done in this case. The second example is an example of a programmatic solution. We had an old master information system, it did its job, but no one had changed it for many years and no one wanted to take the risk. We needed information for a high volume and rich of Kafka events. There was no service returning the requested data, and even if it had been, the performance was not good enough. The solution was to periodically fetch information directly from the database and update a Kafka state store. The Kafka state store was used to the enrich operation. This solution is not what you would find in an architectural best practice book. It is a pragmatic solution that delivers value to a small cost. As the data model has not been changed for more than 10 years, it's likely that this solution will work until the master information system is replaced. We had an old system called by sending binary buffers to MQ. The response came on MQ as well. We needed to call it from a client only talking REST. We also needed to translate a key by looking it up in another system. The solution was to create a facade service, calling the two services and making all technical stuff with binary buffers and MQ. The REST service interface is done according to the future architecture and may remain unchanged when the old system is replaced. The last example is about an old integration platform that did its job well. It handled a lot of unrelated areas. It was time-consuming to maintain and change. In some areas, we also needed token-based security, which this integration platform did not support. When there was a large change in one area, we created a new integration microservice for that area. We also tried to get the clients to use the new services. When all clients in an area had moved to the new services, we removed the old ones. This was a stepwise move toward the future architecture. It's easy to introduce and deploy as old and new services may live in parallel for a while. After some years, most areas have moved out of the integration platform. So how do we simplify lifecycle management, like Java updates and introducing new versions of frameworks in new systems we build? Normally, the updates are easy done but the problem is time-consuming manual regression testing. This makes the developer think, I do not risk breaking anything by introducing a new version, even if it would simplify my current task. Newer frameworks make it possible to start a full version of the system with an in-memory database, an in-memory messaging system, and so on, when performing the JUnit tests. This makes it possible to test each scenario automatically end-to-end, including security and configuration. The JUnit tests actually perform a REST call to the service actually stores information in the database, and so on. This is a help for the developer during development and maintenance, but it also helps during refactoring and performance updates. All regression tests are done in minutes and finds unwanted side effects before the code is even checked in. And it's also a help when lifting Java version or versions of frameworks. You start by lifting the version or versions, then you run the regression tests, and that is done in minutes instead of days if it had been manual testing. You then fix possible problems and rerun the tests. When the tests are greens, the update is done. We have found that this way of working makes version updates a side effect of other development tasks. It normally only takes minutes. In contrast, updating a system with manual regression testing may be a full project. This is not a help for already existing systems without tests, but is something I would like to recommend when you build your new systems to be able to perform better and faster version updates in the future. Thank you.
Okay, so we just heard Anders talk about different ways of going about modernizations, going into some real-life examples about modernization patterns. But now the question is, how do we actually implement those modernization patterns? And what kind of technology platform should we select? I will now introduce the Quarkus platform for those that haven't already heard about it. But in short, it's a modern and flexible microservice platform, which is meant to be container native. And you can use it to easily interoperate with, adapt or replace old systems while still using modern technology. But let us zoom out for a little bit and look at the bigger picture. What kind of requirements do you have on a modern platform in your organization? Of course, it will be very different depending on where you're coming from and what kind of competence you have focused on. But I will go through what I think are some base requirements when selecting a modern platform. I think it should be runnable on some kind of container platform. And why is that, you might ask? But I think a key thing is that you get homogeneous deployment of your applications, so they all deploy the same way. It's also very easy to provision up new environments. For example, if you want to spin up a test environment for a new project, or scaling quickly in production to some new feature you want to launch. There are also many operations benefits, for example, the availability of the platform, and it's also quite some nice tools to do rolling deployments to reduce downtime during a deployment. You can also get some quite nice benefits with effective resource use, where you have your container orchestrator that distributes your loads across a set of hardware. So those are some key base requirements. But then, depending on your organization, you probably have a lot of other requirements, like it should integrate with this and this system, it should run with this build pipeline. And then you can have some more niche requirements that I think also a lot of modern platforms can fulfill. For example, high scalability, if you want to scale to handle a really high load in production. Or you might require elastic scaling, that you can scale your load, your deployments with the load that's coming in. So for example, at peak, you run 20 instances of your service, while in the night you might only run 5. And that could save you some money, for example, when running in the public cloud. And if we step back a little bit more to see what kind of journey are we looking at here when moving from older platforms to modern platforms? Well, one recurring theme is more like a philosophical way of looking at your services. You might have heard people talking about pets versus cattle. So typically your older systems would, in this analogy, be more like pets. You care very specifically about the system, it has a name, it has to run it in its certain habitat with all these little helpers and scripts to keep it going. While in the more modern view of these modern platforms and microservices, you tend to view your systems more as cattle. You don't care about a specific instance, you care that they are easy to replace. For example, this is what enables you to do these rolling deployments and just throw away the older instance, bring up a new one, and have it run quickly and flexibly with some new configuration or just maybe using more resources or some other configuration change. But if we then get into Quarkus, what is it for those who haven't heard about it? Well, if you read on the website, it says that the tagline is a Kubernetes native Java stack. And it also says that they have a high focus on a low memory footprint and a fast startup times. The project is quite new. It was started by Red Hat in 2018, but it's still been developing at a pretty rapid pace for being this new and had a lot of new features and improvements during that time. But what is it exactly then? Well, it is a Java framework and runtime, similar in scope to Spring Boot. Of course, the ecosystem is not as large as Spring Boot or Spring, which has been around for a long time, but it's still pretty big. But one of the key features of Quarkus is the focus on supporting Graal VM-based ahead-of-time compilation. So Graal VM is a project out of Oracle that allows you to, instead of compiling your Java code to this bytecode that can run on any platform, you compile it specifically to a binary that can run on a specific platform. And why do you want to do that? Well, it's because of these gains you get from that allows you to have a lower memory usage and maybe a fast startup time. Is that important for you? I should say also all Quarkus applications can run the normal way without doing this ahead of time compilations. And there are different pros and cons to selecting either way. But if we move out to the technical specifics and instead look at more the developer experience. So Quarkus allows you to do both a more typical traditional imperative programming style, but also supports the reactive paradigm and this more asynchronous way of thinking about your program. It also has great support for different kinds of standards and libraries like CDI for dependency injection, JAX-RS for REST services, and different kinds of standards and libraries. For example, Camel if you're doing a lot of integration work. There are also a lot of modern conveniences for you as a developer, a very quick live reload feature, and this kind of simple configuration mechanism that you typically find in other modern platforms, such as Spring Boot. If we move on to look at the specifics about the memory and startup times. So here is a performance diagram taken from the Quarkus website. And here they've compared Quarkus running in two different configurations, the ahead of time compiled one and the JVM normal one, to a more traditional cloud native Java stack running on the JVM. And this, I believe the cloud native stack they're comparing to is this Thorntail project. But I think you can think about it as a Spring Boot similar thing. But of course, if you're concerned about comparing to specific alternatives, you should do your own evaluation to see what kind of numbers you get for the scenarios you want to compare for. But I think this can be pretty representative. So what we see here is that for this REST example project, even running Quarkus on the JVM saves you about half of the memory footprint. And if you instead move to the Graal VM-based ahead-of-time compilation, you're almost at 1/10 of the memory consumption of this traditional cloud-native stack. And if you look at an example with REST and CRUD, for example, with persistence, the differences are not as huge, but they are still pretty significant. And if we instead move on to look at the response time, so this is the boot of the application to the first response time of a REST call. you can see there are already pretty big differences comparing the traditional cloud native stack to Quarkus on the JVM. And if you look at the ahead of time compiled version, it's really, really quick. So this allows you, for example, to run these kind of serverless applications where you have this scale to 0 on the first request you start up your application. And it also allows you to quickly scale elastically if there's a cluster of requests coming in at the same time. You might want to scale up your service very quickly to meet that demand. But I encourage you to do your own testing to find out if this is the kind of gains you can see for your own application and domain. So now we'll actually go into the meat of this part, which is a Quarkus demo based on a case which has this kind of theme of modernization with older systems in mind. So let's imagine we have this old product master data system, which might be a little bit slow to serve requests. It might be hard to change. And then you get some new requirements. You want to serve a high volume of requests with low latency. So in this scenario, we'll imagine a Quarkus microservice to implement a cache to solve this problem. And if we look at this little diagram I drew here, you will find it's very similar to one that Anders showed before. So we have this old system exporting data through a REST call with a little adapter so that it ends up on a Kafka topic. And then we'll consume from that topic in our new Quarkus microservice to implement this cache. So let's go into the demo. So here we have the implementation of our product data cache in Quarkus. So this might look familiar to you if you would work with frameworks such as Spring Boot or something with JAX-RS annotations. It's a similar principle. So we have our class here, and we have some annotations to denote how it actually exposes the REST endpoints. So here we have something at the base path of product. We're going to serve JSON to the client. And here is our specific REST endpoint. So you can query it with a GET operation with a specific product ID as a path parameter. This maps to an argument in this method. And we use this product ID to do the lookup in a cache. The cache is simply a concurrent hash map, mapping an integer to a product object. So looking at the definition of the product object, it only has a few fields: the product ID, name of the product, and the category. And this is pretty standard. We just look up the key in the hash map. We get the product, we check if it's a match, we do some logging. If there's no match, we throw this exception, which would give us the 404 HTTP error. So pretty standard for an HTTP operation. And the interesting part is perhaps how all of this links into Kafka. And here we're using something called microprofile reactive messaging and a specific connector implementation called smallRye Kafka. But basically how we use this is that we have an annotation here to say that this should consume from the products channel. And then we have our method that takes then a product and what we do with it, we do some logging and we then put it simply in the cache. And we'll look into a little bit how all of this is wired together with the configuration. But all in all, it's a pretty simple, fits on one screen, but still implements our kind of caching behavior and consuming from Kafka. So let's have a little look at the configuration here. So basically, we say where the Kafka server is at. We specify what kind of reactive messaging connector we're going to use. And then we have to specify this deserializer class, which I will mention later as well, to say how we're going to deserialize messages on the Kafka topic. And here we map this reactive messaging channel to a specific Kafka topic with the name products. They happen to be called the same. We have some options for exposing a Swagger UI for a REST endpoint, which we'll use to actually do some testing. And this part here is then a bit unfortunate, but so GraalVM is a pretty new project and it has kind of a bit of complexity in that it has to be able to compile for different platforms such as Mac OS X, which I am on now, which apparently is a little bug around. But I think it's more stable for compiling to Linux, which is what you typically would do if you do some kind of Docker image build of your application. Anyway, it still works to compile a native image, as I will show you a bit later. And just having a quick look at this deserializer class here. It's pretty just some boilerplate, and you might think, why do I actually need this? Can't this be inferred? Maybe there is some optional plugin to kind of generate this one, but the base difference here to more traditional Java frameworks is with graalvm to build this kind of binary, you cannot rely as much on reflection, or at least not in the same way without some configuration options. So you have to be more explicit about what classes you are going to use and how you're going to use them. This is my understanding at least, but this is not too hard to implement. We simply point out the data model class here and do a boilerplate implementation of some class here. So this is basically it, and we'll move on to a little bit of testing of this. I've included here a Docker Compose file that allows us to easily bring up a one-node Kafka cluster to test with. And we're going to be sending in two different kinds of messages here. One with just product ID 1, toothpaste, in the category of hygiene. And then we have a simple update of this data here, where we change the name to strawberry toothpaste. So I have TV-checked the setup a little bit. Here we have my Docker Compose running Zookeeper and Kafka. Here I have a console which would allow us to... I wrote a little wrapper script to be able to send these messages using some Kafka CLI tools. And we'll just simply send in this JSON file. And here we'll start up our service. And now we're going to use the Maven Quarkus plugin, which allows us to do this live reload mode. We're not going to get into it, but this is typically how you would start it in your developing process. So we see it starts pretty quickly. It writes some things about the communication with Kafka, and we will send a message here. And I can tell you that since this is using some Java tooling behind the scenes, it actually takes a second or something to start up the JVM. And this is the kind of a startup time you can avoid with Quarkus and doing ahead of time compilation. So we see that it logged down here that it updated the product cache for this product. And if we then instead move on to look at the Swagger interface here, we're gonna be able to see our service, hopefully. Yes, we can. So here is the generated Swagger UI for this REST endpoint. We see our product endpoint here, and we can try it out then. Put in a number, product ID 1, we execute it, and we get this content we sent in with the initial toothpaste name. We'll just send a quick update here with a second version. Takes about a second to start everything up there. We can also see our query log here, and that we both did the query, and now we update it again. We will look at the update quickly here. So now it updated to strawberry toothpaste. So we have our microservice implemented. It was pretty smooth running. I will just show you briefly. I'm not going to show the compilation of the ahead of time binary, but I have done it here before. So we have both our typical jar, which is the normal thing you're building with Maven and Java application, but this here is another binary built with graalvm, and I'm just gonna show you quickly how fast it is at starting up. Very quick, and maybe you won't be even able to tell the difference, but if we're gonna start up the jar instead, it takes, well, maybe, I don't know, 100 milliseconds extra at least, maybe half a second. So I encourage you to experiment with this yourself and look at the memory consumption and everything. But I think it's a pretty nice framework and allows you to write pretty concise implementations. So I think that was it for the demo. We'll just sum up with some final words here to recap the presentation. So Anders was talking about a lot of real-world examples of modernization patterns. And I think the key take-home message there is to be pragmatic about your modernization steps and have a clear roadmap what you want to achieve. And when you're evaluating what new technological platform to use, you should clearly evaluate your requirements against what's out there. And I would say you should strongly consider Quarkus as a platform for implementing such modernization patterns and other services in your organization. So thank you for listening to this talk, and I hope it was interesting for you.
So we are back in the panel yet again. And as you can see, we are one more now than before the session. That's because Björn has arrived. Welcome, Björn.
Thank you. Glad to be here.
Really glad to have you here. How are you doing today?
Pretty good, pretty good.
Pretty good?
Stressful day, but yeah, always fun when things happen.
Always, as a developer. I mean,
yeah.
it's stuff to do. Super interesting session. And we have had a lot of questions in the live feed as well, which I would like to take here in the panel so that the people watching can get some answers. And we can start with, it's Eric Forslid wondering about Quarkus, which is your area of expertise. It's a pretty young platform, Quarkus. Do you see any risks with that, using it? Or can you discover elements where you haven't been exploring before using Quarkus?
I guess, of course, there's a risk with the new technology. For example, maybe the Spring Boot ecosystem is more mature, and the Spring ecosystem for sure has been around for a long time, so they may be more battle-tested. But still, it's also based on a lot of common technologies that in themselves have been battle-tested. But then, of course, if you're running this Graal VM-based compilation, that itself is also pretty new and has certain parameters and behaviors, maybe the odd bug as well. But I think, yeah, the performance characteristics can be different when you do this ahead of time compilation. So you really have to do a little testing yourself and determine is it like fast startup time and low memory that I want, or maybe there's some other performance characteristic that is better by running on the JVM.
And we saw some examples there earlier in the session as well, when Anders were presenting some real case scenarios. Would you consider Quarkus as a possible implementation platform for those examples?
Yeah, I think it should definitely be considered as an option, but then you have to consider, of course, your team, your experience. I'm definitely not saying that yes, today, tomorrow you should start replacing everything. That's a microservice with Quarkus, but you should definitely try to see if you can find a case where it fits for in your organization. For example, at my current position, we're looking at, so we have some microservice that we're going to deploy a lot of instances of. So we're looking into maybe do a proof of concept to see if would it make sense to do this with Quarkus instead? Then we can save a lot of memory footprint, and how would that compare to our current implementation? So it's a pretty small scope of functionality, and I think it could be suitable to try out Quarkus there.
Yeah. And speaking of which, how production ready would you consider the Quarkus demo app to be, which you just showed?
Yeah, it has its limitations, and it's mostly for to give you a short taste of what it could be like to develop with Quarkus. So if you want to do it really production ready, you have to think about how do you initialize all the relevant data every time when I start up in the cache. Or if you do some kind of fancy mechanism with Kafka and log compaction or something like that to make sure that you get everything you need in your cache. But otherwise, in terms of deployment and such, I think it's, there's a lot of stuff already there. And configuration-wise, definitely, it's very easy to make it deployable on a container platform. So I think it's well on its way.
Yeah, thank you for that. We had another question here from Adam, wondering about those unit tests you were mentioned there, Anders. What's your take on more comprehensive integration tests? How could you possibly work with that instead of testing just units?
Yeah, first of all, if we see how we work mostly, we do a lot of system tests where we run it using JUnit, but the whole scope end-to-end for the system. And we work a lot with the API, specifying it. So we have a stable API which we can trust. And when we have that, the integration test is mostly about seeing that all works together. You don't have to test all special cases with that. So I would say you definitely need integration tests, but it's more more of the normal cases, not all special cases. So you can limit the integration tests a lot when you have these good system tests.
All right.
But I would like to add there, so we were mentioning, like, why do you want, when you select your modern platform, why should you aim for running it on a container platform? And one other benefit of that is, I think it changes the economy of doing this kind of multi-service integration test, because on the one hand, if you're doing it container-based, you can be sure that you're using the same container image that you would be using in production. So it's more real life-like, the test that you can get. And it's also on these container platforms, it's easy to spin up for a temporary test, maybe something run with your nightly pipeline or something like that. So I definitely think that you should look into if there are more cases than before where it could be interesting to automate tests between a number of different microservices running in a container platform.
But it can also be of huge importance to show a bit of pragmatism in those examples you are talking about now, I guess.
Yeah, and as you said, like, don't test everything, and especially if you have comprehensive unit tests, then maybe the need for these integration tests is not as huge.
Yeah. And some other wonderings I had taking part of the session is that you are describing your roadmap, Anders. Do you have any recommendations of tasks to think of finding paths to deliver value in an early stage? Because this is a journey we are onto, and things can take time. But during that process, you still want to deliver value. Obviously, a really broad question, of course. But do you have any recommendations or tips, so to say, regarding that?
In many cases, what you need to do early to deliver value is often that you read information from different systems. And that you can, in many cases, do with a sort of pragmatic solution. It's always harder when you should update the information. So think about what type of information you can read if you can deliver value, because often value is in information that you can present. So that's one tip, at least, that you can think about.
Absolutely. It's a great one. Before wrapping up here, I would like to have asked some final questions regarding Quarkus. Also that a pretty broad question, but what would you say, Björn, is the best thing about Quarkus compared to the other platforms you've been using?
Well,
What does
of
Quarkus
course,
have?
it has its unique value proposition of doing this ahead of time compilation. But so that's a big one, and maybe the thing that would probably motivate you to switch from another framework. But still, I would say that it really seems to be focused on the developer experience. So I think that's also a big plus for it.
And to finish this question session, I would like to ask you guys, I mean, we have Quarkus, we have a lot of really great open source, OpenShift platforms to use. But it's still about cultural adoption as well, right? Working with that new technologies. It starts with a will to innovate, I guess. So it's always important to really have that in mind while trying to find new solutions.
Yeah, I guess like this is like if you're curious and trying out new platforms, then you probably have some passion for your work, and you want to deliver a good technical solution but also this thing about that you're having a good time while doing it, and you have all the conveniences, the support of doing like your unit tests and live reload or whatever you need, and so that you feel that you have all the tools there to do a good job.
Yeah, you can always start with a small microservice, maybe not the most important for your business. So you can start in a small scope with that.
Being pragmatic.
Yeah, exactly.
Guys, thanks a lot for taking part here in the panel and for the super interesting session as well. Having that said, we are soon running out of time for this meetup. We are really grateful to have you all watching. Thanks extra to our partners, Red Hat and IBM, for making this event with us. And also, of course, thanks to all the speakers, in particular, Kim Clark and you guys. And also thanks to Oscar Schnell being with us, answering questions in the live feed. We are soon back again with new exciting meetups, so stay tuned on our channels, and we will see each other shortly again. So thanks a lot, and have a great evening now.